Good morning. My name is Elliot Kane, and this is Daniel Mendelli. We are Team FM Approvals, and we worked on automated light intensity for visual notification appliances with our technical directors David Waite and Aaron Cunha. FM Approvals is a company that certifies products with a focus on property loss prevention. With that being said, our project motivation was to automate the light intensity measurements for fire alarm strobes as part of the certification that shows that the strobe is an effective visual alarm. Our project impact will save time, effort, and promote safety in the workplace. We are proud to say that our best anticipated outcome was achieved. What that means is that we created a fully automated system to record and compile light intensity measurements at each angular combination, and it's ready to be deployed on day one. Key designs of our feature include the design of the hardware fixture itself, the automating the stepper motors as part of the fixture, and then creating a fully functional GUI to facilitate testing. First, the design of the fixture. We redesigned it based on what they had with automation in mind. Now, we're not mechanical engineers, so this was a bit of a challenge, but what we did was we put three manual linear translators on the bottom half here, and then we put our stepper motors on the top. That places the minimum weight on each motor and allows us to use the same motor to help simplify our design. Next, automating the stepper motors. Previously, we had automated the stepper motors using a simple Python program. However, we later moved to the Kinesis API. This is the latest software provided by Thor Labs to reliably control their motors. It offers .NET integration, which works great with our graphical user interface written in C#. In our demo, you can see the beta motor on top, which has a range of motion from 0 to 360 degrees, and then the bottom alpha axis motor only needs to move from 0 to 90. Next, we created a SQLite database. SQLite is designed for embedded applications and programs, and it allows us to store all of the information that our program uses in between sessions. It offers C# compatibility, Python compatibility, and saves all of our information, and that includes information about the test, it includes our hardware configuration, and it saves our measurements as they're taken. Creating and designing the SQLite database from scratch is one of the biggest challenges that we were able to overcome during our project. Here in our software block diagram, I talked about the motor controller and elements of the C# GUI, including Thor Lab software and the SQLite database. Now I'll hand it over to Danny to talk about the rest.
Now, our biggest challenge this semester was to design a fully functional graphical user interface to house this entire system. Now, we wanted this interface to have a few key features, letting the user first input all the necessary test information before simply selecting a standard to start a test. After that, they would be able to track the progress of a test as it's going on and interact with it from there. Now, as you can see here, this is our fully functional design. In the middle here, the user would just input all the necessary test information. Then after that, just simply selecting a standard and starting a test. From here, the user can interact with it, gathering live measurements, as well as pausing, resuming, or aborting it entirely. Feel free to come by during the demo session to try it out for yourself. Now, looking more into the back end of how it was developed, this was written all on the .NET framework in C#. Now, our original idea for this GUI was to design the shell of the GUI in C# and have the Python scripts work on the back end. Now, this proved to be a huge challenge as we weren't able to easily interact between the Python scripts and the back end. So after some discussion, we decided to migrate much of our logic from Python directly into what are called C# background workers to handle all of the automation. And this worked great, but it proved to be a challenge as we had to retest and make sure everything worked as expected. This backend also connects directly to the database in order to update with live measurements, as well as calling a Python script in order to create the output file at the end. Now, looking back into the GUI, if the user wanted to, say, modify the standards that were already there, they would click the Modify Standards button, and this new window would appear. From here, the user can simply select from the list of standards if they want, add on to it or edit it, as well as delete it entirely. the user can also create a new standard from scratch, and all of this gets updated to the database directly. That way the user can use the standard right away. Now, one of our biggest challenges this semester as well was to migrate all of our automation of the light sensor into the back end. Now, this proved to be a big challenge because last semester we used the ILT 1700, which provided a one-way serial communication with the use of a microcontroller. And now trying to migrate this into the C# backend was a huge challenge as it provided much less reliability. So after some discussion, we decided to upgrade to the ILT 5000, which provided a much faster API as well as using two-way serial communication, negating the use of a microcontroller at all. This also provided much more accuracy in our flash detection, as well as providing some more features, such as estimating a flash's duration. Now, due to this being a different API than our original one, we had to rework our logic in order to get it fully functioning. Now, at the conclusion of a test, the user will want to export the data into a spreadsheet format. Now, this will get called through a Python script and generate a file as seen here, which will contain all of the angle measurements as well as the light measurements taken at those angles, as well as any test information that the user may need. Now, in order to finalize this project, we wanted to easily package it up and ship it off to FM approvals to work on their PCs. So in order to do this, we used the NSYS scriptable installer to create a setup wizard that we can easily migrate it and package it up on location. So with this installer working and the entire system working correctly, we wanted to document exactly how to set up LumiNotify as well as how to just run a basic test. So we decided to write a manual from scratch in order to document how to set it up and how to use all the features in detail. So now that we had all of the hardware, software, and a manual set and ready, working all together, we're proud to say that we have achieved our best anticipated outcome, and we'd like to thank all of those who have helped us along the way. Thank you.